voice is good for, putting people to sleep, at least in this class, right? After lunch and our bellies are full. Okay, so first of all, Killington, Vermont. You guys know what they do in Killington, Vermont? Kill people? What do? They ski or snowboard, I guess. And I guess sometimes people do die because it is kind of a dangerous hobby. People get killed. Okay, they die. I mean, they get killed by gravity, I guess. Anyway, back on track here. So, this is the place where you go skiing, right? And again, it's, let's pay attention here. Pay attention to the time that we're given, okay? Midnight and 10 a.m., right? That's our time here. So you can see, where's our x-axis? Our x-axis is not labeled down here. That's because where is our x-axis? It's up a little bit, isn't it? Why is our x-axis not down here but up here? So it can be negative numbers, right? Because temperatures can go negative, right? And so in this case, we're going to have some negatives. Now, if you look here, it's saying the time of day is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So what are these numbers representing? The time, but the time, like, so 1 what? 1 o'clock. 1 o'clock what? A.M. in the morning. Yeah, in the morning. Okay. 1 a.m., 2 a.m., 3 a.m., 4 a.m., so on and so forth. Okay, all the way up to 10 a.m. Okay, so that's important to recognize, right? Also, these are temperatures over here, and thankfully we've turned back to the American label of Fahrenheit. Okay, so more familiar to us here. You can follow, where the temperatures go down to about, what do you think maybe the lowest temperature is there?
Negative 20.
Negative 20 is the lowest listed, but on the graph, the lowest is about negative 15, I think I heard. Yeah, Tyler said, I think I like that. Yep. And then what is the highest temperature it goes up to here?
35.
Yeah, maybe about 35 or 36 maybe. Okay, and again, with some of these things, we have to do a little bit of interpretation, right? We have to try and ask ourselves, the people that are asking us the questions, are they looking for us to be approximate or are they looking for exact kind of stuff? And we'll kind of have to figure that out as we go, kind of feel it out. Okay, so letter A asks us here, what was the temperature at 6 a.m.? So let's go to Catherine. Catherine, can you tell me what was the temperature at 6 a.m. according to this graph? 20 degrees. Okay, yeah, very good. How'd you figure that out, Catherine? What'd you look at?
The sign and then look up.
Okay, yeah, so we found the 6 there. Look up, and then from here, what'd you do from here?
Went that way.
Went over, yeah, to find the matching 20 degrees. 20 degrees. And I'll put a little F there for Fahrenheit. Okay, is it necessary to put the F? Oh, yeah. Okay, good job, Catherine. Well done. Let's go to Mark. Mark, what was the temperature at 7:30 a.m.?
At 7:30 a.m. it's like 25.
Okay, let's see here. So 7:30, well, there's 7, there's 8. So to find 7:30, Mark, where should I go? In the middle. And then we're going to go up, 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 up. So let me just look right there. What would that temperature be?
Oh,
30 degrees, yeah. Yep, 30 degrees. Good job. Okay. Now the next question. Oh, Sean, question? Sean, you got to start going during lunch or something like that. But if let's wait till after this, though, please. Thank you. Yes, let's wait till after this. Thank you. Okay. All right. Letter C. When was the temperature? Now this is different. We're not talking about the time, right? We're now given a temperature, and when was it? So when was the temperature? -4 degrees. Okay. We'll have to kind of this one might be a little bit trickier here. Okay. So I'll take volunteers for this one. Someone want to volunteer? When do we see a time when it's going to be -4 degrees? Let's go to Dylan.
12:30.
You said 12:30? All right, so let's see here. So here's 12, right? Or 0, 0, if you want to say that. But 12 and then 30. Okay, I can see that being 4. So 12:30 a.m. Okay? Very good.
It happens again, too, doesn't it?
Ooh,
Yeah.
Alex, yes. Very good. All right. All right, so Alex, where else does it happen?
I would say around 3 a.m.
Okay, exactly 3 a.m.?
I'd say around,
So
might be about somewhere.
at 3, we're maybe a little bit more than halfway. I'd say maybe 3:30 or 3:20 or something like that. 3:25, 3:26. Okay, but you guys get the idea, though. Okay, you get the idea. Try to be precise. Okay, try to be precise.
Thank you, Mr. Limbaugh.
Thank you, Alex, for your help. That was good that you recognize that. Was that the only, so wait, now are there only 2 or is there another place where it's negative 4 degrees? There's only 2. There are only 2. That's right. Okay, so then how about 8? How about 8 degrees Fahrenheit? Let's go to Ben. What do you say, Ben? Is there, when was the temperature 8 degrees Fahrenheit? Positive 8 degrees Fahrenheit.
Oh, okay. I know it. Okay, all right. So it was around 8 degrees Fahrenheit at 5.
Okay, around 5. Yep, or you can say 445 there if you like to, something like that. So I don't know. I might say 445, but you guys get the idea there. About 5.
Daniel.
Okay.
Daniel.
Yes.
Hello. Where's Daniel?
Over there.
Did you give me a? Wait a minute. You gave me a. Daniel gave me a warm up. Simon, did you give me a warm up?
No, I forgot to put my name on it.
Did you have them though?
Did you give me a warm up?
Okay, you want to give them to them? Give them to her. Sorry, you get your credit then. Thank you, Simon. Okay, letter E. The maximum temperature. What was the maximum temperature? When did it occur? We already kind of talked about this, but let's go ahead and do it again here. Tyler L. What do you say, Tyler L? What do you say approximately was that maximum temperature we experienced during this time period?
35 degrees.
Okay, 35 degrees. And you also got to answer though, when did it occur?
It occurred at like 8.
Yeah, I'd say 8 o'clock a.m. I'd say it's pretty darn close there. Good job. And again, Tyler, I know this might be a silly question, but just humor me. How did you determine that was the maximum? What were you looking for?
Like the top, like the highest point.
The highest point, exactly right. Maximum is the highest point. Very good. All right, let's go to Daniel. Daniel, letter F. What was the minimum temperature and when did it occur? Negative 15, very good. And about what time?
Like 1:45 to like 2:30.
Yeah, very good. So there's like an interval here where that happens. So we can like say anytime between 1:45 and 2:30, we can probably say that happened there. Okay. I'm not sure if you're looking for a single answer there or a range, but good identification. It did kind of happen for a while. Okay, well done. All right, let's keep going then. Now here's an interesting, when was the temperature rising? When was the temperature rising? Hannah, what do you say about that? When was the temperature rising? During what times?
Like 7:30 or 8.
Okay. Was that the only time that it was rising?
No, but like also from like 3 to I guess 3 to 8.
Okay. 3 to 8, I would definitely say that. So from 3, if we start at 3 a.m., we're going up, 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 up. Okay. Did it start? I think it started rising a little bit earlier than that, though, too. Yeah, maybe about 2:30 to. I'm sorry, off the screen. There you go. Maybe about 2:30, but then definitely ends at 8. Very good. Okay. Yep. Now, is it rising? Here's a question for you guys. Is it rising at the same rate from 2:30 to 8? Is it rising at the same rate the whole time from 2:30 to 8? What do you guys say? No. Okay. What gives it away that it's not rising at the same rate the entire time from 2:30 to 8? Tyler? Okay, yeah, it spikes at 7, and like sometimes it's more flat, sometimes it's more steep, but it's always going up, right? That's what the important thing is here. Matt, question?
I'll do the next one.
Do the next one? All right, so Matt T, when was the temperature falling?
I said 12 to 2.
Okay,
and then-
12 to 2.
And then I said 8 through 10.
And then what else?
8 through 10.
Oh, very good. It's falling here, okay, but it's also falling up here, okay? And, you know, again, you guys can, like, you know, kind of make a little decision for yourself there, but whether that's flat or not. I kind of agree with Matt that it does kind of look like it's decreasing still there, but if you think that's flat, I get it. You might want to say then only 8 to 9, or maybe 8 to 9:15 or something, but definitely starts at 8, and I'll go ahead and say 10 there, because, yeah, it does look like it's going down very slightly, very slightly. Okay? Would a graph of the temperature at our school show the same kind of points? What do you think?
No,
No? Why not? What do you think, Erica? Why not?
because it's definitely a lot hotter here.
It's definitely hotter here. Yeah, I would agree. I would agree, right? You're freezing, okay, but are you really freezing? It's definitely not negative 10, negative 20 degrees, you know, kind of thing, right? We probably won't even get to the peak today or even tonight. You know, like we won't get to 35 degrees today or tonight.
Until winter.
Not for a little while at least, yeah. Or later in fall too sometimes. So yeah, so the answer is no. Sorry, the answer is just no then. Okay. And so, well, we kind of answered letter J as well then. Would it have the same Y values?
Yes.
Like on a day like today, let's say.
No.
No, right? And again, for what Erica said, our temperatures are higher than that. Matt, you have a...
I said yes because technically the numbers were still there, but it's not going to get down to that low. So technically the numbers would still.
But it won't have the same value.
It does say a typical January day.
Oh, where does it say typical January day? I missed that.
The top real look.
Oh, like, so you think we're supposed to compare it to our typical January day?
I don't think ours gets down to negative 15, but
Well, yeah, I don't know. Sometimes, you know, okay.
I think the 20 to 40 is about the only
And then the other days
reason.
that's snow.
Right. No, I know. We do have like weird stuff. So, I mean,
Global warming is like
no, I mean this one. Okay, I can see what you're saying. So, it depends on how we want to interpret the question. If we're going with what Erica says, Erica's like today these temperatures are not going to be this low. We would say no. If we want to go with what Matt says, well, in January the temperatures might look like this. We could say that too. So, you know, it depends. I guess I'll say, and we'll just leave it at that for right now. I'm more concerned about the earlier questions anyway. So it depends. We'll just put that for right now. Okay. I'm okay with that. Okay, just it depends. But hopefully the questions on the test will be a little more clear. They should be. Okay? All good on that? All right, so that was just an experiment there with kind of like understanding how to read the graph in a context and all that, okay, pulling information out of it. So it seems like you guys are pretty solid on that. I got one more paper here we're going to work through some practice, okay?
Mr. Win, my
Yeah.
book sitting board.
What's the matter? Do you not need them right now? No. Yes. But be quick because we are learning this stuff. So now we're going to remove the context. We're going to remove the story. We're just going to have a graph. This can make things, bless you, sometimes easier. It can also make some things harder, right? So it's a mix.
that means the other side would know, right? Heads up, come on, I know it's Friday, we're all so happy.
That's right.
Oh my
Heads up,
God.
7 up.
Heads up, 7 up.
Yeah, I remember playing that inside before recess.
Right. Yeah. 2:15. Let's play. Come back.
That's a good
We'll play at 2:15.
We should play one with that question.
Nah, maybe. Oh, okay. Well, there you go. Some people do though. They don't want to be left out. You got one for yourself, Miss Mulcahy? Okay.
Oh, what? No.
There you go. Okay. So we've taken the context out. No more story, just a graph. Okay? So again, makes it a little bit easier in some cases, makes it a little bit harder in other cases, right? So some things we won't have to like interpret our answers in terms of the graph, right? Before when we saw behavior, we were like, oh, this means temperature's going up, temperature's going down, temperature's this, that, whatever that thing, or what times and stuff. These are just numbers now, okay? But the idea is still the same. We're going to work here on describing the domain, okay? The domain describes the x values, or the x-axis. Okay, that's right. Now, in this case, our graph. Oh, okay, it doesn't say it. We're going to do this first, though. Is this graph continuous? Oh, it does say. Is this graph continuous or discrete? Continuous. So is this relation continuous? Yes.
It will be -4 to 6.
All right, hang on. We're going to get to that. Okay? So, since the graph is continuous, am I going to list out a bunch of individual numbers for my domain? No. My domain will be an interval. Interval, which means I need a starting point and I need a stopping point. I'll just put a comma between them. Okay? Now, hold on a second. I'll get to you, Alex. Let me ask my question first, and then we'll see if you still want to answer. Okay? For the domain, okay, we're dealing with x values. That means I want to know what's the farthest left I'm going to go, what's the farthest right I'm going to go. Notice that there are arrows at the end here, folks. Okay? Caden, what's the farthest left we're going to go? Negative infinity.
Oh, good job.
Okay? Matt T, what's the farthest right we're going to go?
What is it, positive infinity?
It'll be positive infinity, yes. And notice I'm not using the square brackets because when you deal with infinity, right, you can never get to it. Square bracket means you include that number, but you can never really get to infinity. Okay? So, whenever you were like in elementary school and you're arguing with someone like, yes times a million, yes times infinity, and then someone will be like, yes times infinity plus 1. You know? There's not really a difference there. It's infinity is infinity, okay? So, anyway, it still sounds more impressive, I guess. But, that's your domain. Okay? That's your domain. Negative infinity to infinity. Okay? That's it. All right, let's talk about the range then. So now the range, we deal with the what coordinates? Y, because I wanted to know. All right, so, Mr. Wood, don't quit your day job. All right, so, range, so we're dealing with y coordinates. That means we're dealing with the lowest y coordinate and the highest y coordinate. Again, this function is continuous, so therefore, am I going to list out just a bunch of numbers for my range? No, okay? What is the lowest y value here? Let's go to, oh, poor Sean, he's in the bathroom. He's not going to answer from there. Matthew, what do you say? What's the lowest y value we're going to go to in this case? Yes, because we have that. What's this? What tells you that we're going to go to negative infinity here? There's an arrow pointing down. Exactly right. Matt, what's the highest? Matt Estill, what's the highest y value we're going to get to? Positive infinity. Very good, because again, arrow pointing up, so it keeps going. Okay, good job. Domain is negative infinity to infinity. Range is negative infinity to
Because the arrow
infinity.
is
Bless you.
going up and down on both ends, then the domain and range are always going to be infinity. Yeah, I thought so.
If we have arrows, if we have not always, but in this, it's the way they're pointing. It's the way they're
I'm
pointing.
sorry, but I'm looking at this. I mean, this -2.
Uh-huh. The -2 right here, like this point right here. Okay, so that is something. Okay, that is something. We would call this, and I don't think you guys need to worry about this, but I'm going to tell you to anyway. So you might want to say, Mr. Wid, though, we do have this kind of like bottom point right here. Like, shouldn't we like maybe call that a minimum? And the answer is yes, that is called a minimum, but it's not the minimum. The minimum indicates the lowest point. There is no the lowest point because we keep going. But, Ms. Mulcahy, there is something called a relative minimum relative to the rest of the graph around it here. That is a minimum point. So relative minimum. But you guys don't need to worry about that. Also called a local minimum. Unless you go to calculus. And believe it or not, there are people, there have been and there still will be people that start out in year-long algebra and make it all the way to calculus. And that could be you. Like you wanted to. That people do it. Okay? If you guys know who Ramike is, she started out in year-long algebra and now she is she's in calculus, A-B-C. So she's gone from where you are all the way to like one of the most advanced math classes in this school. It's possible.
What's the most advanced?
I mean, probably AP Statistics or AP Calculus. Those are college-level classes that we teach here at the school. So,
What's the easiest?
the easiest, I think Statistics is probably like easiest math class overall. That's a good question. I guess it really depends because I think all math classes can be difficult for someone depending on, for me, any of these math classes would be easy. Just kidding. I think probably contemporary math would be the most easy for one for me, maybe. Because it's like mostly like arithmetic and like just like doing bills and stuff like that. And like I'm an adult, so I already kind of know some of the stuff. Although you do have to learn how to do taxes in that, and that could be tricky because I use a software program to do my taxes.
Wait, you have to learn how to do taxes in that?
They teach you how to do your own taxes, yeah.
That's what they're
I
teaching
didn't
us.
Oh,
know
is that right?
Contemporary.
Oh, well then, you guys would be good to go if you ever take contemporary.
Taxation is tough.
So yeah, it is, But hey, you also like having roads, don't you? And police too, and military. So sometimes you got to pay for it. Anyway, moving on here. Zeros. Zeros, okay? Another way to think about a zero, x-intercepts. Okay? X-intercepts only. Okay? So, do you guys know what an x-intercept is? Okay, well, so let's try and break it down here. X-intercept. So it's where the graph intercepts or intersects the x-axis. Okay? Does our graph intersect the x-axis? Yes, how many times? Ooh.
3 times.
It is 3 times, okay? Now, that's not going to answer our question still, though. We have to identify where it intersects the x-axis. So, let's see here. Sky, can you tell me what's one of the locations where the graph intersects the x-axis? -3. Okay, and so that is a x value or a y value there? It's x. So, yeah, we have a 0 at x equals -3. All right, Hannah, can you give me another 0, please?
4. 0.
Okay, so x equals 4, yes, or you could put the coordinates 4, 0. That's another thing, too. Yeah, you could also put -3, 0. Your choice about how you want to list it there. Either just the x coordinate or the x and the y is fine. Okay, and then last one, Catherine. So we got that 0, we got that 0. Catherine, what's the other 0 we didn't list yet? At 0 is the graph. Oh, well, that's crossing through the y-axis. Where else does the graph cross through the x-axis? Right here. Besides at -3, see it's crossing through at -3. And besides at 4, see it's crossing through at 4. Where else, Catherine, does the graph cross through the x-axis? Look at here's the x-axis right here, right? Where else does the graph cross through? Do you see it?
-1.
Yes, very good. -1. See, you do know. Very good. Okay, thanks for still sticking with it. Okay? There are 3 zeros. Is this relation a function? Ooh. What's the test that we use to determine if something's a function or not? Mark, what do you say? You remember what the test is, Mark, that we use to determine if something's a function or not?
You switch it
Switch it? What do we switch?
with the letter. Yeah.
Switch the letter. I'm not sure what you're talking about there. Oh, I think you're talking about inverses. Like you switch the x and the y's or something? Not quite. All right, let's go to someone. I'll call on some of these. How about Daniel? Do you remember how do we determine if something's a function or not?
I don't know.
What the test is that we use?
The line test.
It's been a while. Yes, the line test thingy. What kind of line do we use, Reagan? You remember what kind of line?
Straight
Yeah,
line,
it's
yeah.
straight. Okay, but every line is a
Vertical.
straight line. What?
Vertical line
Vertical line test. Right. So, okay. So Daniel, now that I've jogged your memory, Mark, now that I've jogged your memory, Reagan, not me, sorry, Reagan and Dylan has jogged your memory a little bit about the vertical line test. Okay. Does this pass the vertical line test? Is this a
Yes.
function? Reagan says yes. She's giving you some help, maybe. I don't know. Do you think she's right or not? What do you think?
Yes.
I don't trust Reagan.
But Sky's still going to say yes, right? Because he's right, okay? She's right. The vertical line test says that if you can draw any vertical line and it will only hit the graph once, it's a function. Any vertical line we draw here, it will only hit the graph once. So yes, it's a function. Yes. Yes. Okay. Last one, we're supposed to find f of 5. F of 5. Let's go to Carson. Okay, Carson, for f of 5, what is the value of this function at the x value 5?
I don't know.
Okay, so here's the x value 5, right there.
Oh, yeah.
What's the value of the function when x is 5? Here's our function, right? So here's x is 5. What's the value of the function when x is 5? What's the y value that matches with that? Yes. Yes. 5. And then here's where we have x equals 5 on our graph, and that's a y value of -2. Exactly right. That's all you got to do. Just match the point. Dylan, question? After you answer this next question for me. Yes. Okay, we're going to try number 2 now. Okay. I'm going to do the domain and range together with you, and then I think I'm going to let you answer the rest of the questions. Okay, but we'll do the domain and range together first, because that's the trickiest.
What's minimum maximum? Is that like the minimum like the number?
I would say give me the coordinate. Give me the coordinate of the minimum point and the coordinate of the maximum point. Okay, x, y coordinate. Okay, does that answer your question? Okay, all right. Whew. Okay, domain. Back to my original question. Is this function discrete or continuous? Continuous, right? It's connected. Okay, so that means our domain and our range, are they going to be a list of numbers, or are they going to be an interval of numbers? Interval of numbers, okay? So let's go to, man, I keep coming up with 8s here. Daniel, your number keeps popping up, but I'm not going to keep coming to you. Daniel, I'll give you a break here. Sean. Oh. Domain deals with x or y coordinates. X, so x That's left and right. All right. What's the farthest left? What's the farthest left x coordinate we have in our graph here?
8.
Positive 8. You went the wrong direction. That's the farthest right we're going to go. But that's a good number, though. We are going to use that. Do we actually get to the 8? Is there like a point at 8, x value of 8?
Yeah.
Yeah, so we're going to include that. Now go the other direction. You went right. Now I mean say go left, okay? Go left. -6. Do we get to the -6?
Yep.
Well, what do you see at the -6 on the graph?
Ooh,
An
a
open circle. Since it's a hole, do we include the -6 or no? No. Okay. Whew. So we go to the -6, but we don't include it. What kind of grouping symbol am I supposed to use here?
Infinite.
It's like the infinite. What's next to the infinity symbol? What do we have next to these infinity symbols here?
Negative?
Nope, it's the parenthesis. Parenthesis means we don't include that number. Okay? So very good, Sean. Okay, -6 to 8. Don't include the -6, but do include the 8 because we get there. Okay? Why didn't we use infinities here?
Because
Like in the last problem, why didn't you use infinities? Tyler? No, go. You were right, but I want to give Tyler a shot.
Because they're line segments, which means they don't go on forever.
Right, okay, they stop, right? They're finite, not infinite, right? Infinite, not finite. Finite, they stop. Okay, very good. All right, we'll do the range. I'll let you guys try this here next on your own then. So let's go to, all right, Reagan. Reagan, the range deals with x coordinates or y coordinates? Y, okay. So y's, remember, are the lowest and the highest. So what's the lowest y value that our graph hits?
-7.
Very good. Do we actually get to it?
Yes.
Yeah, it looks like it, so we'll put the square bracket. And what's the highest y value we get to?
3.
8 or 3, or, so it sounds like you weren't sure. Take a look here. Take a look one more time, or take a look at your graph if you want to. Okay, what is the highest y value that our graph hits?
4.
4.
Sorry, I was looking up from the
Yeah.
lowest point.
No, that's okay. Yeah, I figured that's okay. That's why I wanted you to take a second shot at it. Okay? All right. Okay. Well, you guys go ahead, do the zeros, do the minimum, do the maximum, find f of -2, find f of 0. You may skip increasing and decreasing, we'll come back to those. So go ahead and try zeros, min, max, f of -2, f of 0. And I'll help with increasing or decreasing. Yes, now you may go. Thank you for waiting. Okay, Matt, question? Yeah. Okay, for the minimum, I want coordinates, blank, comma, blank. Okay, and for the maximum, I want coordinates, blank, comma, blank. Okay, give me the coordinate of the highest, coordinate of the lowest. All right, so go ahead and answer those questions. Zeros where the x, remember, it's where, like we did here, it's where they cross the x-axis or -1. There's some x -1 as well. So it's just the x coordinates where you cross the x-axis. So where do you cross? So like, so here was it x-intercept -3, -1, and then 4. So do that for these then, okay? I'll help you. So yeah, what's f of 0 or what's f of -2? So this is a graph of f of x, right? So find f of -2. -2 is replacing x, so your x value is -2. So here's the x value -2. Where is that on the graph? Right here. So forth. Yeah. You got this okay, Scott? All right. All right. Very good. Thank you.
No, I think it's 4. How do we get
Any questions on any of that? You have yeah. You kind of have like the right idea there.
Yeah.
Yeah. That's really cool. You kind of have the right idea. You're coming up with you're like on the right track. You're on the right track. Give me the coordinates of the highest y coordinates.
Great.
But I'm not.
So we can see that it's increasing from here up to here, right? What are the x coordinates? It starts at -6. And increases up to like -2. So -6 to -2, and you would use an interval. Okay? And there's a second interval where it increases as well. So you can do that. Okay? And then same thing for the decreasing, it's an interval. Okay? we doing okay on this, or you're not sure?
I've helped.
I can help in a second. I just want to see if I can.
Could I also have helped?
Yeah, sure. Okay, so the zeros. Zeros occur when the graph crosses the x-axis. So give me some. So what's that? X equals 1. That's one of them. What's another one?
-5.
X equals -5. Is that another one? And then x equals 7 is another one. Okay, so you want to list all three of those. X equals -5. X equals 1. X equals 7. Okay. But don't put them in like don't put them in interval notation like that. Do x equals that, x equals 1, x equals 7. Okay, don't put them in an interval. Or like that's okay. But x equals.
Sorry.
No, that's okay. Okay, now for the minimum. What do you think the minimum is? It's the what?
It's the lowest.
The lowest point. So locate the lowest point. Give me the coordinates for the lowest point. Give me the full coordinates. So
5, -7.
5, -7. Right? Do you see that? 5, -7. The lowest point is the minimum. So where's the lowest point in your graph?
Oh, the max.
So the coordinates are 5, -6. And then give me the coordinates for the maximum. Exactly right. Okay. I'll be right there, guys. 1 second. Okay, and then I want you to skip these two and then try those two. So where's the maximum? Where's the highest? 1. So okay, that's the y value. What's the x value? What's the x coordinate for that point? For this point, what's the x coordinate? So -2, comma 4. Right? If this coordinate is -2, 4. Okay? Now, we want to find f of -2. We're skipping the increase and decreasing for now. So we're looking at f of -2. Okay? Now you'll notice this is a graph. This is a graph of f of x. We're asked to find f of -2. So that -2 has replaced the x. It is our x. Where on your graph is x equal to -2? Can you point to it for me? Where on the curve is your graph equal to? Yeah. So on the curve, yes, exactly, right there. On the curve, right there, right on there. So yeah, exactly. What's the value of the function? It's 4. The y value is 4. The coordinates. You see that? At -2, the value of the function is 4. It's a height of 4. So your answer is 4. Wait, where is it on your graph? Where is x equal to 0 on your graph?
Where do we get 4?
Equals 4. Sorry? So there's your x is 0. Where is it on your graph? Right here. Okay. Sorry guys, some comment. We're going to do some normals. So minimum. Wait. So where is the lowest point? It's right here. And then you get the coordinates to the highest. We're going to go over it like right now, so just hold off. No, I want you to pay attention because I might call on you to answer stuff.
Yeah, but I can put my calculator away if you don't finish it.
Shh. What if you make a mistake, Matt, and you want to correct things? Okay. Shh. Here we go. 1, 2, 3. Eyes on me, right? No, that's silly. Okay. Anyway, sorry. So, zeros. Here we go. I'm going to call on someone here. Give me some of your zeros. Let's go to Erica. Erica, what are your zeros for number 2 here?
1, -5, and 7.
X equals 1, x equals -5, x equals 7. Or you can give me 1, 0, -5, 0, 7, 0 as coordinates. That's fine as well. But good. Yes, Erica, good job. All right, let's go on to Dylan. Dylan, what is the coordinate for the minimum? Please. Oh, thank you. Sorry, I started to fall asleep there. All right, next one, maximum. Let's go to Liv. Liv, what are the coordinates for the maximum, the highest point? So locate the highest point on the graph, and just what are the coordinates of that point? So let's see, 4, 0 would be right here. That doesn't look like the highest point. Here's the highest point of the graph, right? What are the coordinates right here? Yeah, -2, 4, you got it. Okay? right, you want to do f of negative 2? Okay. Erica, what is f of negative 2?
Oh,
4. That's right. So at negative 2, here's when x is negative 2 on our graph, right there. Right, there's the x coordinate negative 2 on the graph. That's when x is negative 2. And what's the height there? It's 4. That's all you got to do to find that f of negative 2. Likewise with f of 0, where is x equal to 0 on my graph? Right here. X is equal to 0, right? There's x value of 0. There it is on the graph. So what's f of 0 going to be? 2. All right, I want to talk about increasing and decreasing here real quick. All right, I know, running out of time, but I do want to talk about increasing and decreasing, okay? When we talk about increasing or decreasing here, how should we describe where the function is increasing? What should we use to describe it? Yeah, Matt?
X.
The x values, okay. And should we just list out a bunch of numbers where it's increasing, or we should do an interval?
Interval.
We should do an interval here. We're going to do an interval, okay? How many intervals will there be for where the function is increasing? Dos in Espanol, right? Or 2 in English. That's right. Okay, there are 2 of them. So let's start with the first place. Where does it first start to increase? At what x value? So here's where it's starting to increase. What's the x value here? Negative 6. Do we get to negative 6?
No.
No. Okay. And then from negative 6 up to what x value?
Negative.
So yeah. So I see. Well, we will get to the 5 in a second here, but it stopped. This particular part where it's increasing, it stops at negative 2. Okay. Now here's another weird thing. I'm also going to exclude that negative 2 as well. Okay. And I'll talk about that maybe another time. That was one of the intervals. We have another interval. Where does the next interval start where we're increasing? 5, and then it goes to 8, yeah. And then to join these two together, we're going to use this little symbol called union, okay? It's something from set theory. It's like a little U, okay, to join them together, okay? Just a little U. It means union, okay? And then we'll do the decreasing. Decreasing, where do we start to decrease here? At what x value? Negative 2. And then where do we stop decreasing? At the x value 5. And again, we're not going to include. Do we decrease anywhere else besides from negative 2 to 5? No. Okay. So questions on any of that? All right, the last 5 minutes here, I want you to work on number 4. You're going to do domain range, min, max. Where is it increasing? Where is it decreasing? Is it continuous? Find f of 4. And find x such that f of x is 6. Number 4, okay? And if you don't finish it, it will be homework. Okay? Just number 4. Just number 4.